Hi everybody, thanks for joining me today for section 6, where we'll be talking about how to solve inequalities that are using multiplication and division. And today there are going to be two different cases that you're going to learn about, and that's kind of what our learning target talks about. It says I can explain the difference between multiplying and dividing positive inequalities versus negative inequalities. So in the first case here, we are just talking about when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. For example, if we had -4 is less than 6 and we multiplied both sides by 2, it would stay the same. Okay, our inequality stays less than. The same goes for division. Okay, if you were to divide each side of this inequality by a positive 2, your inequality would remain the same. 4 is greater than -6, and 2 is greater than -3. See how that inequality stays the same the entire time through. So our first couple examples, example 1 and example 2, are going to revolve around when we multiply or divide by a positive number. Now that's going to change in case 2. I'm just kind of fast forwarding a little bit here. When we multiply or divide each side of an inequality by the same negative number, the direction of the inequality symbol must be reversed for the inequality to remain true. For example, if I took -4 is less than 6 and I multiplied both sides by a negative number, by a -2, -2 times -4 is +8. And -2 times +6, we have a -12. So notice how in the beginning, my inequality was less than. In the end, it changes to greater than. Whenever you multiply or divide by a negative number, the direction of the inequality must be reversed. So if it was less than, you need to make it greater than, right? So that's how example 3 and 4 will look then. Just giving you a little bit of a preview. So make sure that you highlight those two different cases, and that I might write myself a note here that there's two very different situations of when we multiply and divide by positives versus negatives. All right, let's try an example. It says solve x divided by 5 is less than or equal to -3. X divided by 5 is less than or equal to -3. What is being done to my variable? It's being divided by 5. To undo that, I would multiply by 5 on both sides. And notice, in my first step, I'm multiplying by a positive 5. This is multiplying by a positive, so I don't need to switch the inequality. Multiplying by 5, dividing by 5 are inverse, they cancel. I'd be left with x is less than -15 for my solution, and then graph it. So I'm not going to graph every single one of these today, just for time's sake. So if you need more help graphing, please come see me and I'll help. But it's just a little bit time consuming when I don't want to make these videos too long. So I'm going to try to only do a couple graphing problems. It's less than or equal to, so I need a closed circle at -15, and that's where x is less than that, so I need to shade to the left if it's less than. Okay, go ahead and try 1, 2, and 3 on your own. Please pause the video now. Right, number 1, you should get n is less than 3, and then make sure you graph it. Number 2, you should come up with m is greater than or equal to -5. So I just rewrote it so that my m was first and then my number. So maybe you had -5 on the left and m on the right, and then remember you just need to reverse this inequality. So maybe you had this. Both of these are true, but again, when you're graphing, this is a little bit easier to tell which direction that you need to shade. And then lastly, number 3, you should come up with P is less than negative 9 halves. Okay. So again, maybe you had that reversed kind of like this one. And then graph, if 9 halves is tricky for you to graph, remember it's the same as 4.5. So it'll just be between -4 and -5 on your graph. Please let me know if you had questions on any of these or want to know how to graph them, and I'll gladly go over those with you. Example 2 now, we're using division. But again, notice in our first step, we're dividing by a positive 6. Okay, so I'd get x is greater than -3. Negative divided by positive, we have different signs here. So it's going to be a negative answer. And then I'll graph this one quick. So -2, -1, 0, and getting more negative, -4, -5. Open circle at -3 since it's not or equal to, and then it's where x is greater than, so I'll shade to the right. All right, go ahead and pause again for these 3 triad problems for 4, 5, and 6. All right, in number 4, you divide by 4 on both sides, so you'd have b is greater than or equal to a half. For number 5, we're dividing by positive 12, so again, our inequality stays the same. So k is less than or equal to -2. And then in this one, we divide by 2.5 on both sides. So that would give me -6 is less than q. And if I rewrote that, I would have q is greater than -6. And then again, please graph and let me know if you have questions on graphing. All right, here we are to case 2, where in our first step, we divide by a negative number. Okay, so this changes our inequality. We need to flip that inequality. We need to reverse that inequality for the statement to remain true. So let's look at how that works. I've got -3 halves n is less than or equal to 6. So n is being multiplied by -3 halves n. It's smushed right next to it. To undo that, I would divide by -3 halves on both sides. Those would cancel. Anything divided by itself is 1n. And since I'm dividing by a negative, I'm going to automatically switch this right away. So instead of less than or equal to, I'm going to switch that to greater than or equal to right away, so I don't forget to do that. And now I just have to do a little bit of math. I have 6 over 1 divided by -3 halves. Well, I have a positive divided by a negative, so I know when they have different signs, it's going to give me a negative answer. And then when I divide fractions, I'm going to multiply by the reciprocal. Remember, flip your numerator and your denominator. 6 times 2 is 12. 1 times 3 is 3. And 12 divided by 3 is 4. So I arrive at n is greater than or equal to -4. Again, notice that inequality switched because I divided by a negative in my first step. In other words, if you look at your variable and you have a negative number in front of your variable, you are going to have to flip that inequality. Okay, so when I graph that, -4, -3, -2, -5, -6, I would have a closed circle since it's or equal to at -4. And that's where n is greater than. So shade to the right. That's greater than. All right, 7, 8, 9, and 10 are going to be similar. Okay. Some of these are what I call actual double flips because your variable is on the right-hand side. So when you divide by that negative, careful if you're flipping. You might have to flip a couple times. Why don't you go ahead and pause and try it out now. So for number 7, I would multiply by -3 on both sides. And since I'm multiplying by a negative in my first step, that means I need to switch my inequality. So I'd have x is less than, and negative times a negative is a positive 12. Okay. Again, I switched that inequality because I multiplied by a negative right away. Number 8, I'm going to multiply by -2. That's going to get that's going to isolate my variable. So I'm going to multiply by -2. Now, -2 times a half would be -1. Since I multiplied by a negative, I'm going to switch my inequality to greater than or equal to, and then I'm left with y. But now I want to rewrite this so that my variable is first. So when I rewrite it, I need to change my inequality back. So I come up with y is less than or equal to -1. Notice that I had to switch this twice. I switched it when I multiplied by a negative, and then I switched it again when I wanted to write my variable first, so that it's easier when I'm graphing. So I sometimes call that the double switch. Number 9, divide by 6/5 on both sides, or in other words, multiply by 5/6, multiply by the reciprocal. You should end up at m is less than or equal to -10. And here you multiplied by a positive in your first step, so you don't need to switch it right away. Okay, and then in number 10, again, we're going to divide by a negative right away, so we should switch it. So we should arrive at h is greater than or equal to, I flip that inequality, 20 you should arrive at. Okay. Let me know if you have questions on those at all. Again, dividing by 2/5 on both sides, -2/5, is the same as multiplying by the reciprocal. So if you're wondering how I got 20, 8 times 5 is 40 over 1 times 2 is 2, and 40 divided by 2 is 20. And I flipped my inequality because I divided by a negative in the first step. And then you have to graph as well. So these can be a little bit time consuming because there are quite a few steps that you need to follow. My advice to you is to make sure that you're writing these down. It's so easy to lose track in your head. It's a lot easier to just write it down on a sheet of paper when you're solving these. Okay, last example says a submersible, so submarine, descends 37.5 meters per minute. Descends, so we're going down, 37.5 meters per minute from sea level to explore a recent shipwreck. The shipwreck rests on the ocean floor at an elevation deeper than, so less than, -3,810 meters. The elevation of the Titanic shipwreck. How long does it take the submersible to reach the shipwreck? Okay, so we're trying to find how long that takes. Well, I know it descends at 37.5 meters per minute. So descending would be -37.5 meters per minute. Per means multiply. Do I know how many minutes it takes me to get this steep? No, that's what I'm looking for. I'm looking for my time. So I'm going to call that t. So 37.5 meters per minute, which I don't know, so I'm going to multiply these two. That needs to be less than, because it's deeper than, -3,810 meters. Okay. How long does it take to reach the shipwreck? So if I if I solve for t here, that should be able to tell me how long it takes. Well, t is being multiplied by negative 37.5, so I'll divide by negative 37.5 on both sides. That'd be okay if you use your calculator for this. Anything divided by itself is 1t. Since I'm dividing by a negative, I'm going to switch my inequality. And then if you divide 3810 by 37.5, you should arrive at 101.6, and that's minutes. So if we were going 37 meters per minute, it would take us 101.6 minutes to get to 3810 meters, okay, below sea level. Now, you can also think about this in hours if you want. So how many hours would this be? Well, subtract 60, because there are 60 minutes in an hour, so there'll be 1 hour would be 60 minutes. And 41 minutes would get us to 101. And then 0.6, convert 0.6 of a minute to seconds. So there's 60 seconds in a minute. So what's 0.6 times 60? 0, 36, and move my decimal one spot. So that would be 36 seconds. So it takes 1 hour, 41 minutes, and 36 seconds to get 3,800 meters below sea level if I was going 38.5 meters per minute. Alrighty, that wraps up section 6 here. Again, the biggest idea that I need you to take away from this section of solving inequalities using multiplication and division is that when you multiply or divide by a positive number right away, so if you have a positive number in front of your variable, your inequality stays the same. But when that's a negative number in front of your variable, you need to switch that inequality. Okay, thanks for checking this tutorial out. I'll see you guys next time.